So, I apologize for the sound in the last video. I don't feel like we're recording it, so you'll have to deal with it. Sorry, but this should sound better. I now have my circuit, and I'm ready to start moving towards making a PCB. But I need to do a couple things first. And if you notice, there's a bunch of buttons up here. There's buttons for plotting and printing it and rotating and finding and replace things, refreshing, zooming in, zooming out. We can show history hierarchies. We can rotate items, mirror items. And these three are for managing all the parts available. And these buttons here are what we're going to need to generate our actual PCB. So we're going to start with this one here. And it says fill in schematic symbol reference designators. What the heck does that mean? Well, fill in means, apply stuff to. Schematic, the thing we're looking at. Symbol, each of these is a symbol. Reference designators. Reference designators are sort of like names. You see all these question marks on the screen? These question marks of to be named. And if we go and click that button, it's going to do it automatically for us. So annotate and close. Now this is LED 1, resistor 1, LED 2, resistor 2, switch 1, battery 1. So it automatically numbers them. If we had to change our circuit, like let's say I decided to put a third LED pair in, I might want to regenerate those automatically. When I do that, the best option typically is to reset the existing annotations and start over. So now we have our basic setup. It's time to see if our circuit is actually a circuit. So we're going to run the rules check. So we're going to run ERC rules. And if it comes with no errors, everything's good. If you have an error at this point, we'll have to diagnose what's wrong, and you'll have to ask Mr. Spooner or go look online. But this time I got no errors. Common errors are not having circuits connected properly. If your wire terminates on like not the end, but like on the middle of a symbol, or if you don't use a battery, you don't have your power and ground flags. This circuit, we'll talk about that later, but this is our circuit and we're good right now. So our next thing is that we now need to tell KiCad what each of these pieces looks like. And I say, what is the actual component? Now, what is, this switch looks like that, and these LEDs look like this, and these resistors look like this. So we need to get the appropriate footprints. So we're going to click on the bulk edit symbols, and we're going to go one. So first one is the battery. So we're going to click on the footprint, and we're going to click on the library button, and we need to go find a battery. So just like always, we're going to search for battery. And now in battery, there are tons of different batteries. And we're looking for a AA battery. So CR22, Keystone AA. And this AA, if you look at the bottom, has 2 holes. And this has 2 holes. So that's the exact thing. So I'm going to grab that one. I'm going to hit enter. And now it has a symbol. Now we're going to go for the LED. It's going to have both same LEDs. So we're going to click on things. Again, we're going to search for LED. And we want a through hole LED. And we want a 1.8 millimeter. Nope. So that's a standard one. I think I'm going to want these to be horizontal. So I think we're going to put them in the board this way. And we need, I believe, 1 point. These are 3.8 millimeter. And we'll go sort of right at the edge. That looks good. So 3 millimeter, yeah, that looks good. Oh, okay. Yep. This is how high they are. So we want 0 millimeter. That's the one we want. The Z is how high, because this is actually a 3D object. But we're going to grab that. Now our LEDs. Next step is our resistors. So we're going to type in, we're going to move this window so you can see it. And we're going to do resistor. And we want THD for through hole. And we want just a single. We want axial. 2.5 millimeter. That's probably what we have. And we'll do the short ones. So that looks good. And now we're going to do our switch. And this is going to be the hard one for us because we're using a little bit different on the switch. But switch through hole. And we need a 3-hole one. We can do piano, slide. Ooh, 9, slide. Push, 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 push. Tactile. No. Angled, angled, angled. Let's try switch slide. Yeah, flick. So 3 holes together. That's a right angle. So that's very close to what we want. We can use that. We'll just bend it onto the side. So we'll hit that. And we'll hit OK. We're now going to save our project. In the next video, we'll take and start laying out the PCB.